Hi, in this video I'm going to talk about the PBL of Physics 2. First of all, I want to say that this PBL, for the solution, we need a system that involves the transfer of heat and temperature. And for this, we found that the law zero of thermodynamics is going to be useful. We're going to have two formulas. The first is m times constants times delta t is equal to m2 times constants 2 times delta t2. We're going to solve this for Tf, that in this case is our T of equilibrium. This is the T of equilibrium, and it's equal to m mass 1 times C1 times T1 minus m2 times C2 times the temperature 1 in the second substance divided by m1 times C1 minus m2 times C2. This is a formula that relates the law zero of thermodynamics, and it can say the temperature of equilibrium that in the system we have, if two substances are in contact and are in transfer of heat, this is in function of the temperature. And with the other problem, the other part, we have this other formula that relates the heat in function of time. If we have solved this for T, we have that T is equal to Q, that is the heat, times D, that is the thinness of the recipe that contains the fluid, and K, that is the constant of the fluid, times A, that is the area, times the temperature initial by the temperature of equilibrium. We can see in this that everything is constant in this formula: the grosor, the timeless, the constant, the temperature initial, and the temperature of equilibrium. The other thing that it changed is the area of contact. So, in fact, we can say that the temperature, the time is proportional to the area. And for this, in the second problem, we can see that have two systems. In the first is open, and in the second is closed. So the area of the open system that is in contact with the environment is this part plus the part of the recipe that is in contact with the fluid. And in the other, the only part that is in contact is the part of the recipe that is in contact with the fluid. As we can see in the two systems, the open system has more area in contact with the environment. So, in fact, the time will be smaller than the closed system. This is because the area is in less contact. The same pass, but in a different way, with the first part of the problem. all the coffee is concentrated in one part. So you will have more surface of contact in the coffee that mix the exhaustant than in the other. So in fact, the time will be longer in the substance that doesn't have a mixture. That's it. And on balance, we can conclude that the area of contact is bigger. The time that the substance have an equilibrium point of temperature will be smaller. Well, thank you.